Hey, and welcome to this lesson on roots and radical expressions. Our essential question and objectives for this lesson: what does it mean to find all real roots, and how do we simplify radical expressions? So we're going to define roots, find all real roots, and then simplify radical expressions. Our standards: apply and extend the properties of exponents to solve problems with rational exponents. Write expressions in equivalent forms to solve problems, and extend the knowledge of rational functions to rewrite in equivalent forms. So pretty much, roots and radical expressions. If a to the n equals b, with ab, with a and b real numbers, and n a positive integer, then a is the nth root of 2b. For example, I always like to use this example. It's nice and simple. 2 squared equals 4. So 2 is the second root, or the square root, of 4. Another example, 2 to the third equals 8. So 2 is the third root, or the cube root, of 8. Another one, 2 to the fifth equals 32. So 2 is the fifth root of 32. If n is odd, there is one real nth root of b, denoted in the radical form as the nth root of b. That's how you say that, the nth root of b. So if n is odd, like 2 to the third, that means 2 is the only real root of 8. 2 is the only fifth root of 32. If n is even and b is positive, there are 2 real nth roots of b. So for example, 2 to this second power, so n is even, 2, and b is positive, 4. There are 2 real nth roots of b. Those are positive 2 and negative 2. So plus or minus the nth root of b. So, for example, plus or minus the square root of 4, which will give us plus or minus 2. If it is odd, if n is odd, we already went through that. What I meant to say is that the negative root is its opposite, and if b is negative, that means there are no real roots. So if 2, for example, 2 squared equals negative 4, or if just b equals negative 4 and you're asked to find the real roots, there are no real roots, because no two numbers multiplied together will give us a negative number. And 0 is the only nth root of 0. And one more thing, for any real number a, the nth root of a to the n equals a if n is odd. So, cube root of 2 to the third, well, that's just going to be 2. If you have something like fourth root of 2 to the fourth, you have to make sure you write the absolute value of 2, which would then just equal 2. So here we're asked to find what are the cube roots of 8 thousandths, negative 1000 or negative 1000, and 1 over 27. So when we're asked to find the cube roots, that's the same as the third root. So what's the third root of 8 thousandths? So pretty much what multiplied by itself 3 times is going to give us 0.08, and that would be 0.2. What multiplied by itself 3 times is going to give us negative 1000, and that would be negative 10. And what multiplied by itself 3 times is going to give us 1 over 27? Well, that would be 1 to the third over 3 to the third, which equals, if I take the cube root of all that equal 1/3. So my answer, 0.2, -10, and 1/3. Here is a look at your homework on roots and radical expressions. We're going to start off with a little review, circling the exponents just so that you know what exponents are. Underline the expression that is read 5 to the second power just so you understand how to read these expressions. Then you're going to go into vocabulary builder, really understand what a root is. You're going to use that vocabulary to mix and match some things. Just going to review your key concept that we learned in the lesson, and then we're going to use that to find all the real roots in certain questions. Make sure you review back to the lesson. If you have any questions, reach out to me on BBI email, text message, or phone call, whichever is easiest for you. All my contact information is on the Moodle page. For this class, you can meet me in the Math Cafe Monday, Tuesday, and Wednesday at 11 a.m. Or if that doesn't fit your schedule, you can go to the Math Cafe anytime between 9 and 3, Monday through Friday, and there will be a math teacher in there to help you with any questions you have on your assignments. Make sure you come to live class where we can discuss this a little more. Good luck on your assignment, and I hope you had fun.